Wassce practical concept, analytical chemistry.
Hello, lovely people. My name is King Solomon, and this class is basically for chemistry practicals. That is what's the concept, chemistry practicals. So now, chemistry paper 3 is the chemistry practicals in secondary school or high level of education, particularly in the West African uh, examination, the WAEC Council. And I'd like to bring some concepts in the chemistry practicals that help us understand. Now we know that with chemistry, the practical aspect, the questions you normally answer, the first part is the quantitative analysis, the second part is the qualitative analysis, and the third part becomes with general knowledge you know in theoretical chemistry. Now, what I want to do here is that I want to bring light to how we can tackle questions on the quantitative and we can tackle questions on the qualitative. So now, how do we get the quantitative and the qualitative concept? Now, we have what we call analytical chemistry. Analytical chemistry. We have what we call the analytical chemistry. Now, under the analytical chemistry, there are two branches under analytical chemistry. We have one, the quantitative analytical chemistry, and you have the qualitative way of analyzing chemicals. So there is a quantitative way of analyzing chemicals, and you have the qualitative way of analyzing chemicals. Now, both of them, how do we understand it? Listen, when we come to the quantitative way, the quantitative way is very simple. That is to say, we want to find quantity. As from its name, we want to find quantity. For qualitative, we want to find the quality, the quality. So for instance, if we go outside and we want to get food, we normally say that meals, we don't care about the quality of the food, but we do care about the quantity of the food. So now what it simply means is that, for instance, I want to get any food outside, I go to the one selling the food. When I get there and I need quantity, I buy more. If I need quality, I can go to a better place of getting a good food, but I'm interested in the quality of the food, not necessarily the quantity of the food. So for instance, those that sell the gari and beans, you realize that when you get to those places, the reason why guys we like that food is that with little money you can get the quantity. But if you want to get a quality food, you need more money to get a quality food. I don't know whether you're getting it. So if you go check the gobe and beans, the amount of the gobe or the quantitative analysis of the gari and beans will be more or less like when I buy 2 Ghana cedis, I am getting 5 grams of the gari and beans mixed together. But with qualitative, when I buy 2 Ghana cedis, or when I go to a place where there is quality, when I'm holding 2 Ghana cedis, I will not get the food in its quality. If I want a quality one, that is to say, I want where they've actually gone through the extraction, a correct extraction process to extract the oil, and the oil has no side effects. They've actually done the watering part of the beans. I mean, they are all in their good state. They are chemically tested. I mean, everything is well in their good state. The quality is very high. Then I need more money to purchase that, and that is the quality we need. So now, the quality or the qualitative analysis is simple to see. When I take a drink, the qualitative analysis is that what do I find in the drink? What can I find in the drink? In the drink, do I have vitamin C in the drink? So now imagine I have a cup of a drink in it. Now qualitative analysis. The qualitative analysis will make me understand that in this cup of drink, what is in this? In this, do I have something like vitamin C? Do I have vitamin C in it? Fine. Do I have like iron in it? Fine. If I have iron in it, then I'm ready to go. I'm very ready to go. If I have iron in this, then it's very good. Now, I can take it and I'll get my strength because that is the quality. The quality is that I want vitamin C in the drink and I want iron in the drink. So what are some of the analysis, experimental tests that can help me detect vitamin C? And what are some of the experimental tests that can help me detect the iron in this drink? And that those analysis falls under qualitative. Now, quantitative comes in to say that now, if you have vitamin C in it, how much of vitamin C do you have? If you have iron in it, how many or how much of iron do we have in it? So we deal with amount. And that is qualitative, quantitative. But knowing what, the qualitative will ask you the question, what is in there? What is in there? And that is what? The qualitative. That is the qualitative. And for your syllabus, that is for the sake of Wassce. Under qualitative, I think most of the ions you'll be looking at is copper. You'll be looking at copper ion. You'll be looking at aluminium. You'll be looking at lead. You'll be looking at iron itself. That's ion 2 and ion 3. So ion 2 plus, we're looking at ion 2 plus over there, we're looking at ion 3 plus over there. So this one is copper 2 plus, aluminum 3 plus, lead 2 plus. And what again we're looking at calcium, calcium plus. You can also be looking at zinc. Yeah, and so many other ions that you'll be looking at. So this one becomes the cations you'll be looking at. For the iron ions, we're looking at the CO3 minus, SO2 minus, SO4 2 minus, NO minus, NO2 minus. Okay, so these are all some ions you'll be looking at in the qualitative analysis. Okay, now when you go deep into it, you realize that most of these ions, during the qualitative experiments, most of these ions will form some precipitate. So there is precipitation. One concept you have to know, one keyword you have to know in qualitative analysis is precipitation. Now, what kind of precipitation is it forming? Is it a colored ion or is not a non-colored ion? It's a non-colored ion. It will either be forming some colorless or white precipitate, or white chalky precipitate, or white gelatinous precipitate. If it's a colored ion, will it be forming a blue precipitate, a pale blue precipitate? Will it be forming something like a reddish brown precipitate? Will you have a yellowish precipitate? So when we start with the quantitative analysis and we are dealing with the cations, we will look at those that will be forming the precipitate, those are the colored ions, and those which are the non-colored ions. Now, when we come to the quantitative analysis, which will help us detect the amount of the ion in the substance, or the amount of the particular element we are looking for, or the particular compound in the substance. So now, under the quantitative analysis, there are some analysis we do. One, basically, we can do volumetric or titanometric analysis. Two, we can also do the gravimetric analysis. And three, we can do the spectrophotometric analysis. Spectrophotometric analysis. Okay. Now, for the sake of secondary school or high school, what you guys do in your experiment is the volumetric or the titanometric analysis. So this is what you're doing, the volumetric or the titanometric analysis. But to give a recap or to briefly go over what you guys do under the qualitative analysis, that is under the titanometric analysis. And that is why you in school, you call it what? Titration. That is why you call it what? Titration. And you realize that with titration, there are two basic things that you need. You have a solution of a known concentration, and you have a solution of an unknown concentration. So now in titration, there is what? A titrant, and two, there is what? Analyte. There's a titrant and an analyte. So the titrant here is a solution of the known concentration. It's the solution of a known concentration, and the analyte is the solution whose concentration is not known. So now realize that with titration, we are using the titrant to titrate the analyte. In other words, we are using the titrant to find the concentration of the analyte. We are using the titrant to find the concentration of the analyte. And that is basically what we do with titration. So you realize that some of the apparatus we use in titration or volumetric analysis is one, you always hear of burette. So apparatus in titrimetry. Here's one, you always hear of burette. Two, you always hear of pipette. You need your volumetric flask. You need your volumetric flask. Four, you need your white star. And I would like to give the function of the white star. I'll give the function when I'm done listing the apparatus. 5, you need your retorte stand. You need your retorte stand and its clamp. Let me see it that way. You need your retorte stand and the clamp. Yeah. And 6, you need some beakers. Basically. So now, with the titration you'll be doing, there are times you either be having, so when you take this as your retorte stand, there are times, okay, so let's use this diagram to explain the concept, and I'm hoping you get it very well. Okay, so now, when you check this very well, this is our retorte stand, and this is our clamp. So on top here, we have also we can add what we call a funnel to the apparatus. So in the titration, you realize that you always put the funnel here in the burette, and the burette has its own readings. Okay. So now what happens is that when you pour you can either pour, depending on the question, you can either put the titrant with the non-concentrated solution into the burette, or you can put your analyte into the non-concentrated solution into the burette. Any of them goes. So now if you put that solution into the burette, the moment you finish putting it in the burette, you have to take the funnel out. It's a precaution. You have to take the funnel out to avoid any wrong reading. So you take the funnel out after you place the solution into it. So down here, you'll be having your volumetric flask. And the volumetric flask will be placed on a white tab. The volumetric flask will be placed on your white tab. And you also need something like your indicators. Okay. So now, the white tile simple is to help you get the clarity of the change in the color of the solution. So as we titrate, so you see that if you have your base solution, then your acid solution will be here. One of them will be the titrant and one will be at the analyte. So if the acid is here, when you are titrating, after you placing the drop of your indicator, what happens is that you titrate by doing the changing the regulating the burette. Now, as we do that, some of the substance or the liquid in the burette will be falling into the substance in the volumetric flux, and there will be a color change depending on the titration you are doing. So this brings us to the types of the titration. We have our simple titration in titrimetry. So we have the simple titrimetry analysis. We have the back titrimetry analysis. We also have redox titrimetry. So for your standard, these are the three titrimetric analysis you'll be doing. So the simple titration, the back titration, and the redox titration. So depending on the particular titration, you observe your color change. Now after observing the color change, to get the clarity of the color change, that is when we use the white tile. So you place the volumetric flux on a white tile for clarity of the color change. Because the first color change is what you need, so that you can stop and you take the readings and you do your calculation. Now, to do the calculation on titration of quantitative analysis, you have to have a good knowledge in mole concepts. So today, I just wanted to introduce to you analytical chemistry, quantitative analysis and qualitative analysis, the difference in it, and how you can go about it. Let's meet in other videos where we move to understanding so many concepts like iteration of standard solution, how to solve a full Wassce question or a full of them question. Have a nice day. Bye.